So, how many of you here today have heard the term harmful algal bloom? Great. Okay. The term harmful algal bloom refers to a large group of freshwater and marine algae species, which can rapidly form large blooms, or clouds of algae, which are a nuisance to other living organisms. Today, I will be discussing a subset of harmful algal bloom species, specifically those which can produce toxins. My research looks into how toxin-producing algae can affect your health and the well-being of the shellfish industry. The toxin-producing algae species Alexandrium monollatum has been in the Chesapeake Bay for decades, but it wasn't until 2007 that it started to produce true blooms. Since that initial bloom, Alexandrium monollatum has formed blooms in the bay almost annually. You can see a bloom here in this photo, right here, where the water appears a dark brownish color. This water is filled with tens of thousands of cells per milliliter of Alexandrium monollatum, many of which are part of long chains like you see here. The first few years of Alexandrium monollatum blooms in the bay were accompanied by mass mortalities of oyster larvae, veined rapawhelk, and cownose rays. This caused concern among the shellfish industry and the scientific community. We all wanted to know, how toxic is this species? What impact could it have on the shellfish industry here in Virginia? And is there any risk to human health associated with these toxins? This is where the work done in my lab comes in. I decided to start out by looking at direct effects of Alexandrium monollatum on adult oysters. How do we do this? First, we raise batches of Alexandrium monollatum in the lab. Then, I put different amounts of the Alexandrium into jars to simulate different bloom intensities. I put an oyster and a little bit of food into each jar and let the oysters feed for 2 days. This study lets me see how oysters might fare in different bloom conditions. So far in the lab, we have noticed that oysters exposed to Alexandrium monollatum do feed on this toxin-producing algae. Interestingly, most oysters that were exposed to high amounts of Alexandrium shut their shells, didn't feed for that first day, showed signs of reduced health, and some died. This means that Alexandrium monollatum may be affecting the oyster's health, and that oysters exposed to Alexandrium may be accumulating toxins. If an intense bloom were to go on for a week or more, it could have devastating impacts on oysters or other shellfish, which could have a huge negative impact on the $45 million Virginia shellfish aquaculture industry. But the industry's biggest nightmare is having their shellfish product make someone sick. There are a number of naturally occurring toxin-producing algae that are already known to cause human illness. Here's generally how that process works. Shellfish that are in a bloom feed on the toxin-producing algae, and the toxins collect in the meat of the shellfish. Shellfish may eat enough algae to make them toxic to anything that eats them. If these shellfish are harvested as food, the people who consume them may become ill, or in rare cases, could die. You can see then why there is interest in finding out if Alexandrium monollatum has this potential. The most direct way to test whether or not Alexandrium monollatum causes health risk to humans would be to get some human volunteers to eat shellfish that have been exposed to Alexandrium and wait to see if they get sick. Unfortunately, no volunteers have come forward yet. So instead, we have to use indirect methods, swapping humans out for other vertebrate animals. I will be using striped bass. These fish serve purely as a stand-in for humans, and in the wild would not normally consume large quantities of oysters. But they can give us a good first look as to whether or not toxin stored in the shellfish has health impacts on a vertebrate organism. So, how does this actually work in the lab setting? The process will be very similar to the first study, except that once the oysters have fed on the Alexandrium, they will then be shucked and fed to striped bass. I will then watch the fish for any signs that their health has been affected. by looking for organ and tissue damage under a microscope, and by recording any deaths. I will also be collecting samples during the study that will allow me to quantify how much toxin is in the Alexandrium, the oysters, and the striped bass. One of my goals with this research is to provide information to the Virginia Department of Health that will allow them to manage Alexandrium monoletum blooms, identifying if and when shellfish are toxic and pose a risk to human health. This will help the shellfish industry ensure that their shellfish are safe for harvesting. This is why understanding the impacts of toxin-producing algae is essential to your health and the well-being of the shellfish industry.